Hey guys, welcome to the 6th lesson in financial modelling. Last lesson, I think this week, hopefully, we looked at applications of arithmetic series and sequences with some really disgusting track ones, and basically they're really complicated setups to just get to the formula. Today we're doing the same thing with geometric series. I'm filming this directly after, so my brain is mush. We're going to have a crack. Again, I've got the formulas handy. You might like to do the same. That is for any term. This is for the sum. Again, we've got two versions of it. The first one is when one is bigger than the ratio, and the second one is when the ratio is bigger than one. And finally, we have our limiting sum formula, which I don't believe we're going to be using today, but it's there, just so you know what that is. Okie dokes. So, question 1. Grab your highlighter. We're going to be using that a lot. Erica earns a $65,000 salary in her first year of work. Two things here. Whenever I see a number, I'm going to highlight because that number it's maths. It's going to come into the question. The second thing is the word first. Okay, first generally is going to imply that's my A term. Okay, cool. We already got A. Now, this isn't arithmetic, so we're not looking for a difference, we're looking for a common ratio. So we're looking for a multiple in these questions. So each year she receives a 2.5% pay rise. And that's all the information we're given. So we must be able to deduce our ratio from this setup. Now, whenever you see a percentage in maths, it's usually helpful to be writing that as a decimal number. If you're not sure how to do that, percent literally translate to out of 100. Grab that 2.5, divide it by 100. It's just a decimal now. So we've got 0.025. Now, the problem here with it being a pay rise is if you were to grab 65,000 and you were to multiply it by 0.025, you're going to get a number that is much, much smaller than 65,000 because that is how much it is rising by. But what we are trying to summarize, what we're trying to find is her salary each year with that added on. The way I want you to think about increases, because this is going to be quite a common setup you'll see later on, is whenever we're increasing by a percentage, what we're doing is we're getting our full amount, which is just 1, it's our whole, and we're increasing it by that number that represents that percentage. So the actual rate at which I'm increasing is the whole plus that interest rate. I hope that makes sense because that's going to come up a lot. You'll see there's percentages here, there, and everywhere. Okay, so that's going to be our rate. You write this as a decimal, dividing it by 100. If you're not sure how to do that, type into your calculator, it's fine. And then we need to add it to 1 because we are increasing. If this was a decrease, I would go 1 minus, okay, relating it back to the whole. Now it's not going to be too bad. So we need to find her salary in the 6th year. That must be T6. Now, again, because it just says what's her salary in the 6th year, that's just the 6th term. And then it says how much will she receive in the first 6 years. Hopefully what you can realize there is that that is inclusive of everything beforehand. So that is going to be the sum at 6. Okay, so we've got everything we need. It's just a formula. Get in and go. So we know that I might work. I'm going to have to go down. Okay, so for question 1, A, we know that A, her first year is 65,000. We know that her rate of increasing is 1.025. And I know that I am looking for T6. So I'm going to use the formula over here, just up here for the 6th term. I'm going to go 65,000. I'm going to put my rate in brackets because I always like to do that. That way I can't screw up my powers. And then my power is n minus 1, so 6 minus 1. I'm just going to write that as 5. Okay, and then we're just going to pop that into our calculator, and we are going to get 73,541.53383, blah, blah, blah. whenever we're talking money, which is going to be a lot of these geometric, it's getting to financial modeling, right? We are going to be rounding to 2 decimal places because that represents cents. We don't talk about 112 cents, we talk about maybe 95 cents. You can have 93 cents, okay, when we're doing FBOS and stuff like that. So it's going to be $73,541.53. Cool, it's our first actual useful application of geometric series. We found out that in 6 years, she's going to be on that salary. Now what we asked to find for B is, well, what is her total earnings for those 6 years? Now for a geometric series, okay, we can just use this formula here for the sum. And we have everything we need. We have A, we have R, we have N. N is going to be 6 again. Now there's 2 formulas. Generally I use this one when 1 is bigger than R, and I use this one when R is bigger than 1. Because it's an increase, it should be pretty obvious that I'm going to be using this formula here. Again, not the end of the world if you get that mixed up. You might just have to do an extra step sometimes. So for S6, that is going to be, I've already forgotten it, my A, which is 65,000. Outside of, again, I'm going to put my R in brackets just so I don't screw it up, to the power of 6 minus 1. Make sure if you're doing this on your calculator that you don't put something in the wrong spot. And all of this is over R minus 1. Pop that into your calculator and you get an answer of, I'll do it just as the raw number first, so $415,202. I believe that, I can't even read my own writing, how dismal is that? 887, which we're going to round, always rounding money, okay? You can't give a messy answer. $415,202.89. And that's her total for the last 6 years. Okay, so question 2, we have a company with 12 employees. Now that 12, it doesn't say first, but it's what we're starting with. So presumably that's going to be our A. We're going to highlight that for later. It is growing, so increasing at a rate of 20% per year. That's most likely going to be our R, okay? It will need to hire more employees to keep up with the growth, assuming its business is growing at the same rate, okay? So for part 2A, I want to find how many people should the company plan to hire in the next 5 years, and part B, how many employees will the firm have 10 years from now? The reason I hate this question is the wording. In part A, it says how many will it plan to hire. The trick here is this rate, okay, is how many we're hiring, okay? So for this part A, the rate is just going to be that 20% or 0.20 or just 0.2 because that's just the ones we're hiring. For part B, we're considering the whole. We're saying how many will the firm have? So what will its increase be? Okay, and well, I suppose part A is saying what is the increase, part B is saying what is the increased amount once you've added that on. So that R is going to be 1 plus that rate, so 1.2. That got me, 100%. Okay, I hope that makes sense for you, that our interest rate, our growth rate is 20% or 0.2. So if we're just talking who we're hiring, that's just the 0.2. If we're talking about the whole firm, it's including what we have each year plus the extra, we're going 1.2. That's gonna be the main difference here. Now what we're finding is, regardless whether I'm doing just the newbies or the whole, we're doing the totals. So it's gonna be S5 and S10. Okay, so for part A, I'm starting with 12 employees. My growth rate is 0.2 or 0.20 if you want to keep writing it like that. I will, just so you don't get confused as to where that zero's gone. And I'm finding the 5th term. For part B, now I don't normally set out part A and part B at the same time, but I think it's important to understand what separates these questions. A is still 12, Now my rate is 1.20 because I'm talking the whole firm, so they're increased size. And I'm going to be finding S10. Now, we have two formulas. We're going to be using them both. For the sum, you could get away with either. It's not the end of the world, but generally what we do, the bigger things on the left. So we say, well, if 1's bigger than the rate, we go 1 minus r. If the rate's bigger than 1, we go r minus 1. Okay? So for this first example, I have a rate that is less than 1. So I'm going to be setting it up as a times 1 minus my rate to the power of 5 all over 1 minus my rate. Pop that into your calculator and you get 14.9952 people. Does that make sense as a number of people? Probably not. Let's round it to 15. In fact, I should probably use little wavy symbols to say approximately 15 people. Now you could say 14 or 15, as long as you have this line here, you have a little bit of flexibility, but they do definitely want you to kind of round your answer in the end. Okay, now for the second part, we're going to do S10. The difference is I'm going to swap the R and the 1 because this time the rate is bigger than 1. So I'm going to go 12. Now it's still the rate with the power minus 1 all over the rate minus 1. Pop him into your calculator and you will get, I'm just going to have to do it all from scratch. Feel free to skip ahead. Okay, we're back, and I got 311.504 blah, 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 blah. I'm gonna call that 312 people. Rounding up, of course, you could say 311, you could say between 311 and 312, however you wanna word that for yourself. Okay, that is question 2 done. Okay, so question 3, we have the A&I company. They revealed in its 2020, now I see a number, it's a date, it's probably going to be important. 2020 annual report, a yearly profit of $12 million. Again, get into the habit, we're detectives, we're looking for our A, we're looking for our R. All right, now the first thing they give you is usually your A. That means 2020 is my first term. I'm doing this deliberately, that's going to be really important in a minute, identifying the dates as terms. So my A, my first term is 2020, and that is 12 million. Okay, let's keep reading. The company predicts that the yearly profit will rise each year by 5%. Now what we've been talking about so far is writing this as 0.05, and because it's growing, we're going to be adding that to 1 to get our interest rate of 1.05. Now you might notice just here, they actually give us that this time, which is really weird. They don't normally do that, but it's still a good habit to do it ourselves. So the forecast yearly profit forms a geometric sequence with a common ratio of 1.05. Cool, that's what we just found, we're just doubling up there. So for part A, we want to show that the predicted, now they've given us the answer, and to show that, you need to get there yourself. Okay, it's just a check, like having the answers in the back of a textbook. Show that the predicted profit in 2023, now not the total over a period of time, this is just in 2023, is this. Okay, let's start there. Now, I know that A is this 12 million. I know that R is 1.05. The trick with this question is actually figuring out the number of the term for the date. I'll show you what I mean. Term 1, and I generally do this when I deal with dates and terms because I get really confused by it myself. Term 1 is 2020, and that's A, that's my starting term. 1 year after that is 2021, so that must be term 2. Okay, term 3 then must be 2022, and term 4 must be 2023. It can be really confusing looking at 2020 and going, well, 2023, that's 3 years later, that must be term 3. whereas in fact it's actually term 4 because that first term is 2020. I hope I didn't confuse you there, but that's one way I definitely want to set out the dates so I can identify, well, what term is 2023? That's term 4. Now that I know that, I can find it really easily. I know that this is geometric because it told me in the question. I'm looking for the term, so I'm going to be using this formula just up here. I'm going to go T4 is A, so 12 million. Side of R, 1.05. Now n minus 1, 4 minus 1 is just 3. Hopefully we've got that by now. We pop that into our calculator and I get, pretty sure it comes out nicely, 13,891,500. Gee whiz, bit of money. Cool. Now, because this is a show that, my answer needs to be the same as what they gave us, and it is. That's how you know you're definitely correct and you move on. Okay, and we'll go to the next part. Part B, I should say, sorry. We need to find the first year. Now, finding a year, we're going to be finding n, okay, in which the yearly predicted profit is over. Now, yearly predicted profit means term. Again, we're not talking total yet. See that next part C has total in it? That means we're going to be going to a sum. For now, we're still in term form. Is over 20 million. Now, when I set this up for myself, I'm going to be saying, okay, I have my formula for a term, don't I? I just did that a minute ago, it's just here. I want to generalize that for n to get the general rule, right? For any term, I'm going to have 12 million with 1.05 to the n minus 1. Now, I am checking when it's over 20 million. I could do this by setting it with an inequality. I'm just going to use an equals for now because it's going to get me the same purpose. And honestly, it's just a bit more comfortable. Okay, so somebody might tell you, oh, it's not very proper, but screw 'em. So I'm checking when this thing is equal to 20 mil. So I'm going to write it out. In fact, I'm going to cheat because I'm just going to copy and paste it because I can do that. Cool, probably took just as long. And I'm going to set that equal to 20 million because that's what the question asked us to find when it's over that. Okay, and when I find this n, that's going to tell me, well, what year does it hit 20 million? And then I'll be able to go like just after that. Spoiler, it comes out as a decimal, so I'm just going to have to round up to the next year. Okay, so I'm solving for n, it's in the power. We've done this many times. It means it's going to end up being like in an exponential form. It's like 1.05 to the power n minus 1 equals some answer. And I just need to change into a log to get my answer. So I need to divide this 12 million across. Okay, 1.05 to n minus 1. If you divide by 12 million, again, I don't want to keep writing this out because it's getting ridiculous. I'm going to get it down to 1.7, I believe. Okay, cool. That's much nicer to work with instead of all this 12 million garbage. So now I've got it as one base, one power, one answer. I can go into log form, where the log is going to have the same base, but the answer goes here and the power goes on the other side. Now all I need to do is get rid of this minus 1 by plussing 1 on the other side. I could go 1 plus, or I could go log 1.05 of 1.7 plus 1. Now when you pop that into your calculator, and by the way, you could type this in and hit equals at this point and then add 1, or you might like to write it all in one line. I made this point last time, just make sure you separate this thing from this thing. You get an answer of 11.875. Now remember, the question was asking, I believe, find the first year in which it goes over 20 mil. It's clearly in the 11th year. Okay, however you want to write that is fine. So in the 11th year, we went over 20 mil. Towards the end of the 11th year, if you want to be really specific. All right, so part C. Now we're finding the total. Total is a key term that tells us we're going to be using sum for the years 2020 to 2030, giving your answer to the nearest dollar. Okay, so in the same way that I set up this little pattern back here at the start, right? Because I need this for myself. I cannot do these questions without it. Setting up this table really helps me now, because I'm trying to say, well, what must 2030 be? And I could keep going, but this whole topic's about patterns. So what you might notice is that in 2022, it's term 3. In 2023, it's term 4. In 2024, it's going to be term 5. So in 2030, it should be term 11. Okay, it's one more than how many years you've added on. That's the pattern that I'm using for myself to make sense of this anyway. I'm just going to get rid of parts A and B because I don't need them anymore. So what I just figured out is that 2030 is S11. So the sum after 11 years. That's what the inclusive takes into consideration, by the way. So remember what we found. We know that A was 12 million. We know that R was 1.05, I believe. Yep. And now we're just going to pop it into the sum formula. Remember, we've got two options. We have, there's weird little zeros hiding down there. We have a bigger rate than 1, so I'm going to use this version here. So S11 is going to be A. Yes, we have to write it with 12 million. 1.05 to the power of 11 minus 1 all over this. Type it into your calculator and you get the answer. I'm not even going to try and read it as I go because it looks awful. What did we get? Chuck in some commas. 17,048,000 and a bit. Remember that the question asked us to round it to the nearest dollar. So that means looking here, is 59 cents closer to rounding up or is it closer to rounding down? We must round up. So this is going to be 17,048,145. Okay, that's question 3 done. Now we're going to do part 4, which looks unassumingly innocent, but it can actually be quite tricky to get your head around. We are going to be expressing each recurring decimal as a simplified fraction. Now, there are lots of ways to do this actual trick. You can actually do it using fractions and algebra, which is a lot nicer. But we're going to use geometric series because we can. Now, we're going to start with this 0.131313 and so on. What we need to do to approach this, and I'm not expecting you to make this jump on your own. No way would I, but I'm going to show you how to do it. And it's one of those skills where it's probably worth remembering. It could be like a multiple choice question. It could be chucked on at the end of a question. It's just one of those skills. If you let this go, it's not the end of the world. Make sure you can do the application wordy questions. What I need to do here to make sense of this is to break the 13s up into what they represent by place value. What I mean by that is take this first 13, okay? Now, that 13 is 13 hundredths. Quick recap in place value for decimals. If you have a young sibling in year 7, they'll be all over this. We know that this is a tenth. This is a hundredth, a thousandth, and so on. So this point here is a hundredth, th on the end. So this is actually 13 hundredths. Now this number is an addition, so a culmination of all these parts. So I'm going to add on the next part. That next part is 13. Now, an easy trick here is the denominator is always going to start with a 1, and the number of zeros tells you how many places down you have to go. So for this 13, I had to go 1, 2, 3, 4 places down. So it's gonna have 1, 2, 3, 4 zeros. And again, for that last 13, I'm gonna have to do the same thing, 13 over. And hopefully, because this is a pattern topic, you might notice the pattern is I'm just adding 2 zeros each time. Okay, and that would go on forever, right? 13 over, adding 0, 0, zeros. That's one way I can write that number that's gonna be really useful for me. Now, there's a couple of things I can pick out here. I can find the first term, my A. That must be 13 over 100. Cool. Now my R, don't try and figure this out in your head, although you can, because really what am I doing? I'm just adding on 2 zeros each time, so I'm multiplying by 1 over 100. But if that's a bit tricky for you, what you can do, we can use our method where we go, okay, well, the ratio is going to be a term divided, did I miss a zero? Yeah, I did. Divided by the term before it. Chuck that in your calculator, you get 1 over 100. Now, I've got my A and I've got my R, okay? And now you might be thinking, what am I trying to find? Am I trying to find a sum? Am I trying to find a term? Because they don't really make sense. What I am trying to find is what this ends up being. And what this ends up being is another way of saying the limiting sum. This is where this can come into play. That is that bottom formula over here. The limiting sum is saying what does it converge to, even though technically it might not like necessarily be there, okay, in a series, what does it get really close to? And we can use that to write recurring decimals as a fraction. I'll show you how. So the normal formula is A over 1 minus R. And you'll notice I have A and I have R. Let's write it really naughtily, okay, a bit cheeky, with fractions in fractions, because why not? Now my R was 1 over 100. You might like to use some brackets here so you don't screw this up too bad on your calculator, but you can type it in just like this. You can get away with that. If you type that into your calculator, you end up with 13 over 99. Now 13 over 99, I'm not sure. I hope I have a calculator on here. Let's find out. Calculator. Oh, come on, surely. You're joking. Do I actually have to download a calculator? Ugh. Right, well look, maybe you can try this yourself. Oh, I hate apples so much. If you type 13 over 99 in your calculator, do you want to bet what you're gonna get? 0.131313. Okay, we'll do the same thing with B just to really like solidify this and be done with it. 40, 40, 40. And you could do this with bigger repeating patterns like 1, 2, 3, 1, 2, 3, 1, 2, 3. It would just be 1, 2, 3 over 1,000. And then 1, 2, 3 over whatever 3 more zeros is, repeating that pattern. Here, my first term is going to be 40 over 100 because that is the 100th place. 40 over, I'm just gonna add 2 more zeros because that's 2 more places I need to go, and so on. My A is gonna be, I'll keep it in blue, sorry, so that I have some consistency. A is gonna be the first term. You could simplify that if you want. That would be 4 over 10 or 2 over 5. And my R is going to be this term divided by this term. Again, though, you can see that I'm just multiplying it by 1 over 100. Then we chuck it into our formula where we have 40 over 100 divided by 1 minus 1 over 100. And we get an answer that I have not pre-prepared. Maybe our calculator's ready, let's find out. Here it is. So what was I trying to type in? 40 over 100. Oh, goodness gracious, can our calculator do this? Go away. We're gonna, oh my goodness. I know how to use a calculator. Okay, 40 over 100, all divided by 1 minus 1 over 100. And you get 40, 40, 40, 40, 40, but this calculator can't write it as a damn fraction. See, I can't leave it there in a loss. We're gonna have to type it into my calculator. So 40 over, if you're not sure how to put a fraction in a fraction, by the way, that's probably an important thing I should tell you. Hit the fraction button, hit it again. Okay, you can put a fraction in a fraction that way. 40 over 100 over 1 minus 1 on 100. And we get the answer, 40 over 99. Cool, and you might notice another pattern, right? 13 over 99, 40 over 99. Another cool pattern. Patterns all around us. Okay, look, these questions suck. But all I need you to do, pick out a few questions that you can do. We're gonna have some more time in class, so at least if you've watched these videos, seen some examples, maybe you can do 1, 2 by yourself, okay? I think I actually grabbed 1, 2, and 3 as the examples this time because I couldn't find any other good ones, and 4. So maybe start and try and do 5, 6, 7, and we can work through those together. Or at least, have a go. They're bloody hard, see what you can do. There is a whole heap there that you can do if you have time, and there are answers there as well. Again, some of the answers can be a little bit confusing, so feel free to just check in with me as well. For example, this one, I disagree with their wording, whereas there's 2 or 3, because I think it means in total, but Okay, cool. Hit me up with any questions, and I'll see you soon.